Okay, this chapter, this section of this chapter is called angle relationships. Let's jot that down. Angle relationships. So we're just going to show you a whole bunch of different types of angles and how they relate to each other. All right, angle relationships. Okay, the first kind is let's see what they're doing first. They're doing adjacent angles. Okay, so let's talk about what an adjacent angle is. Let me draw a little picture here like this. I'm not going to put the arrows on here at the end. You can if you want to, just for time's sake. And what we have right here, and I'll write the word down, is adjacent. And then I'll write the little symbol for angles. Is that all right? So instead of writing out the word angles all the time, I'm going to write that. Does that make sense? It's angle, picture, right? And then apostrophe S, angles. Adjacent, A-D-J-A-C-E-N-T. Basically, the word adjacent just means next to. Now, kids don't usually say the word adjacent in their normal conversation, but if you listen to an adult, every once in a while they'll say, oh yeah, I live adjacent to the highway, or that thing is adjacent, I work adjacent to the bank, or whatever the case is. It just means next to. So let's take a look at these two angles. I'll just call this angle 1 and 2, make it kind of easy. So angle 1 and 2 are adjacent angles. They're next to each other. Now there's three things that has to be true about adjacent angles. One thing, they have to share, I'll tell you what, I'm not going to write it all down, I'll just write the main stuff down. They have to share a common endpoint. So they have to have a common endpoint. Alright? So these two angles, actually, you know what I should put? I shouldn't put endpoint. What does an angle have? Where do the two rays come together? Vertex. Let's call it a vertex. Alright? Just doing this off the top of my head, so common vertex. Alright? So angle 1, its vertex is right here. Well, guess where angle 2's vertex is? The same spot, at the same exact point. So in order to be adjacent angles, they have to have a common vertex. Number 2, they have to have a common side. They have to share a common side. Right? Which one's the common side? The one where? This bottom one right here?
Yeah.
That's common with both of those? This side right here is the angle 1 doesn't have this side right here. Let's do this. I'll put some letters, make it a little easier instead of just saying that one. Okay. We'll just call this D. Alright, now, angle 1 and 2. See, angle 1 is just this angle right here. Everybody see that? And angle 2 is just this angle right here. Alright, so what is the common side? Give me the common side. It's not C. C's not a side. BC, ray BC, right? If you're going to be really specific about this and really detailed, remember the sides of an angle are rays, aren't they? So the common side would be ray BC. You can't just say C, because C is a point. It's not a side. It's not a ray. So ray BC would be the common side. Now this one's a little weirder to understand. You must have no common interior points. Interior points. I'll just shorten points. Okay? No common interior points, which means this. Let's go to a different color. If I put a point right here, that's in the interior of which angle? Yeah, we can say 1 and 2. It'd be angle 1, right? So this would be in the interior of angle 1. What about, we'll go yellow. I'll try to make it a little thick. What about that one? What is that in the interior of? Angle 2. Can you put a point somewhere that's in the interior of both angle 1 and angle 2? Would that be in the interior of either one of those angles though? No. Remember, the interior's got to be in between them. It can't be on the ray itself. So that's a good guess. All right, that's about as close as you could get, isn't it? To be in the interior of both of them. But it's not in the interior of either one of them, is it? All right. So nope, that wouldn't be. I mean, can I put a point anywhere? What if I go like way out here? No, it's either in what? Angle 1, or the point is in angle 2, and never in both of them. If those three things are true, then these two angles are adjacent angles. You got it? Okay. What if I said this? What if I talked about that whole big angle right there? What would I call that whole big angle? A what?
ABD.
ABD. Okay, so let me ask you this. Is angle ABC, and angle ABD, are they adjacent angles? Well, let's think about it. Look at the whole big angle and look at angle 1, right, or ABC. They do share a common vertex, don't they? They even share a common side, don't they? See this right here and this right here? So BA would be the common side, ray BA. But look at number 3. Do they share a common interior point? Yeah, they would, because look at this green point right there. It's in the big angle, ABD, but it's also where? In an ABC. So that means it would have a common interior point, wouldn't it? Which means it's not adjacent. So these two are not adjacent to each other. Get it? All right. I could give you other descriptions of two angles that are not adjacent, but we got to keep moving. All right. That probably took the longest out of all the things we're going to talk about. It's just vocab, basically, is what we're trying to do here. Let's, oops, daisy. Let's do another one. Linear pair. You've actually talked about linear pair already, but we didn't use that word. Look at this. We'll call that angle 1. We'll call that angle 2. Angle 1 and angle 2 are what we call a linear pair. What does pair mean? 2. So what word is in linear? Not near or not ear. What line, right? Line. So it's a line that has two angles. Look at this. See these two angles right here? They form what? A straight line. How many degrees is a straight line? 180 degrees, right? So a linear pair are two angles that form a straight line, right? And we call that a linear pair. Pair because there's two, and what do those two angles do? They form a line. The word makes sense, doesn't it? Linear pair. Get it? Good. Let's do this. This is an important one. We won't use this so much this chapter, but in another chapter we're going to use this a ton. All right? These are two lines. Give me a nice geometry word. What do those two lines do to each other? Intersect each other. Good. They intersect each other right here. But look at the angles that are formed. Look at 1 and 2. They're kind of opposite to each other, aren't they? And in fact, some books will say opposite angles. This book, and most of the books that I've read, I've used, I should say, use this word. We call them vertical angles. Vertical. Sometimes it confuses people because when they think vertical, they always think up and down. So they think that only 3 and 4 are vertical. But any opposite or any angles that are opposite each other like this, when you have two lines that intersect, the angles that are opposite each other are called vertical angles. So watch. Angle 1 and angle 2 are vertical angles. Now this is free of charge, okay? I won't add this to your tuition bill, but because this isn't in this lesson. But vertical angles, look at this angle right here and look at this angle right here. What does it just look like they might be? It looks like they're equal to each other, doesn't it? Okay, and they absolutely are. Now, don't go by just because it looks like it. There's reasons. We'll talk about it in another chapter when we talk more about vertical angles. But vertical angles are equal to each other. So what are my other pair of vertical angles? Angle 3 and what else? Angle 4. And again, we don't officially know this yet, but what do you think is true about 3 and 4? They're equal to each other as well. So that's kind of cool. All right. They will be, yep. Now, we don't know that just yet. They didn't tell us that. All we're doing right now is defining it, okay? But they are, all right? Vertical angles will always equal each other. Let's do another one. Let's do this. Like that. And I'll put a little box there. What does that little box mean? Right, we got a right angle. But let me put another line in here. Like this, okay? And we'll call this little one down here angle 1. We'll call this one up here angle 2. Now, look at angle 1 and angle 2. They're not necessarily equal to each other. You don't know they're equal, do they? Okay, you don't know they're equal. But what do they form? If you were to add them up, they add up to a right angle, which is how many degrees? 90 degrees. So if angle 1 plus angle 2 is 90 degrees, we call this complementary angles. All right, so complementary angles. Now, let me do one more before you go. What if you had two angles, Watch, it's linear pair, so it's kind of what we learned before. Look at these two angles, 1 and 2. What do they add up to be? 180. We call them supplementary angles. All right? Supplementary. Sorry, I'm running short on time. All right, let me give you a few problems to do, and then you can go. Pages 51 and 52. We're doing 8 to 32. But most of these are you just look at it and say, oh, that's complementary, that's vertical, that's supplementary. You know, it's that kind of stuff. All right, there you go.